Okay, good. Let me open the Word file. Okay, so we were looking into the matrices and arrays.
Yes, yes,
And, we have gone to a point that you said the row operations and everything, they are not there, they removed it. So I don't know how much you need, and now you are okay with the
yes, yes, uncle.
basic structure of the
Yes,
array and why
yes,
the addition works like that, subtraction, multiplication, and division. We need to go for inverse, and hope all of them are okay for you.
yes, uncle.
And we missed the taking the transpose when we find the cofactor.
Yes, yes, uncle.
So that one also we know how what is the mistake we made. So the overall thing is we need to develop ourselves in a way that let's say something is, if you want to even check something is right or wrong what we are doing, can we step back and think about what is the basis of that representation or what is going on. Then once we are very strong and clear with that, we can develop everything completely new from there.
Okay.
Do you understand that?
Yes, uncle.
So let's say if we have a 3 by 3 matrix and I want to find a inverse and everything, I don't know the procedure or something like that, step back, go to the 2 by 2 and easy to do things like, and then even finding the inverse and multiplying the matrix with the inverse matrix, it will tell us whether it is everything is done correctly or not. Okay.
Yes.
So to quickly go for that, okay, let me just want to say that, okay, let's say I have the, why I have to type it every time? Why? Okay. No, why it is not drawing?
Not working.
It's not working. I have the draw. No. Yeah, pen has been selected. Black pen. Okay. What has happened? No.
I think you have to click the draw. Supposed to.
Yeah, now I see the dot. Okay.
Yeah, okay.
So let's say I have 1, 2, 3, 4.
Okay, yes, uncle.
All we know that we need the inverse matrix so that if I multiply this with that one, that will work. So basically, we know that something has to be done, and at least we can start from, okay, I need to find the call this as the our delta itself. So first to find the determinant to see that whether it exists there. So that we know 4 minus, so 1 times 4 minus 2 times 3.
2 times 3
Yeah, that is going to be 4 minus 6 is
minus 2.
here minus 2. Well and good. This is not equal to 0. That means there exists the
Consist.
inverse for that. It is consistent, and the system has the, so this is a system actually. So it can be used later. You will know that even the differential equation, system of differential equations, everything under the eigenvalue problem, everything can be brought upon like a array. That is what the linear algebra is. Okay. So we know that it is not equal to 0. Now let's try to find the delta inverse. So we know at least what to be done. So let's take the delta inverse as the matrix. What we need to do is 1 over the determinant. This is something called normalization, okay? And then it is going to have 4 elements. But now this 4 element is, we need
Uh,
to find the,
inverse of inverse of A can be written as adjacent of A divided by the determinant, right?
yeah, but I'm saying that all this terminology and everything is okay, but I'm saying how to find
Okay.
the elements of this matrix. First of all, we know that leading diagonal has to be swapped. Actually, the transpose is also going to happen. And then depending on the position, the minus 1 raised to the power of I plus j should also work. Do you get that?
Yes. Yes, sir.
So one is here. So the one will stay here. Is that okay?
Okay.
Am I right? No, the 4 will come over here.
4, right? Yeah, that's what.
The 4 will come over here.
4 and then it'll be minus 3.
And yeah, the 1 will be staying here. And this will be minus 3. And this will be minus 2. Am I right?
Yes, sir.
To be more correct, we are all looking for, these are all actually determinants actually. Do you get that?
Okay.
As it is a single element, we did not do that. Do you get that?
Okay. Okay, yes,
So
uncle.
that's the idea, like how we can do that. So now when we put the -2 also into picture, this is going to be an answer of finally -2, 3 over 2, and this is going to be a 1, and this is a minus half. Is that okay?
Yes, uncle.
Okay. So quick check of whether this is a right one or something like that. We can try delta inverse. So that is going to be 1, 2, 3, 4.
Uncle, how did we get the next step?
I
Oh, you
divided,
divided everything by
yeah,
-2?
I,
Okay.
I
Okay.
divided by -2.
Okay. Okay. Yes, uncle. Yes, uncle. Okay.
I think I have done correctly. Yeah.
Yes, uncle.
This is a -2, 3 over 2, and then this is a 1, and this is a minus half. Okay. So when we make the product of that, this is going to be -2,
Minus,
2,
yeah, -2 plus 2. No, -2 might
something wrong going on.
be 0.
No, we need a 1 there, right? If you multiply, it has to be
Yeah.
divided into matrix. No. That is okay. We have a -2 plus 2. We are getting 0, right? Where the mistake is then. If I'm not wrong, this should be 1 and 4 should stay there, isn't it?
One second.
Yeah,
Then,
this is the because we take the and then we transpose also. So I'm saying this is under this is a -2. You see, in that case, this is this also not working. What I made mistake. So 4 minus 6. 4 minus 6 is a -2. Where the mistake is.
uncle, cofactor of A will be 4 minus 3 minus 2, 1.
Okay.
And for getting adjacent, we have to make the transpose, right? So it will be 4 minus 2 minus 3 and then 1.
Okay. Cofactor is bringing the
Is finding the
cofactor is you just avoid that particular row and a column, and we look for the
yes,
remaining determinant.
yes.
And then once that is done, we have to go for the
Transpose of it.
yeah. So they are saying that the -2 and the 2 and 3 will be swapped.
Yes, uncle. Yeah, yes. For adjacent,
So
yes.
that means again something is going on. If I no, I don't have the 2. This is 2 and this is 3. That's what you are saying, right?
Yes, uncle.
And this become a 1 and this is a 3 by 2. So this become
Yes, I'm sorry. -2, 1, 3 by 2 and -1 by 2. That into -2.
No. Okay, 1 second. Let me. This is okay because when we transport, the leading diagonal won't get moved. Do you get that?
Yes, uncle.
So when you first find the cofactor for the 1, then we forget the first row and first column, then only 4 will come into picture. Do you get
Yes, uncle.
So that is what we have written here. So the determinant of whatever the rest of the array. Do you get that?
Yes, uncle.
And then when we go here, okay, of course, we are going to forget about these 2 and only this will remain, and that will be there. And while transposing, this will go to this one. So I think this is okay. This is -2 plus 3. Is that okay?
Yes, uncle.
And then this will be a 1 minus 1. And this will be a minus 6.
You get 1001.
Yeah, minus 6 and plus 6.
Yes, uncle.
Yeah, but don't get driven by we know the answer what we supposed to be. So we cannot keep thinking that and pushing the answers to go there. Do you get that? Most of
Yes,
the mistakes happen there. Okay.
no, I solved it right now. That's
Yeah. That's okay. 3
plus 4 into minus 1 by 2, so it'll be minus 2.
minus 2. Yeah, right. Now I think all good. Okay.
Yes.
So that is going to be a 1 0 0 1. So the lesson learned is not only for this kind of maths or anything. It's like, do we know all the basics about what we are doing? And then if we are doing an advanced procedure or a step in that particular thing, then for the knowledge of what to be done, we can always step back, go to the very basic, and then we can develop completely. We don't need to go and look into the book or any of those things again and again and again. Do you get that?
Yes, uncle.
So that is what we are learning and growing our knowledge is all about. Okay.
Yes, uncle.
Okay. So where you are and what we can do now today.
Today, wave optics was kind of confusing for me.
Okay. So, okay. Again, in physics and all the things, I always told you, like, we need to think about, it's not only learning something as a new thing, but actually we are building up what we already know. And when we learn something which we have not heard about or learned about, then try to connect with already what we know and learned. It may be a different concept or something like that. So everything is all about dynamics. Okay. Dynamics, and then the motion. So it could be either coming from the object or from the energy. So it could be a dynamics of an object. Object, we call that as a motion. And in the energy, it is called the wave. Is that okay?
Yes, uncle.
Energy, it is called a wave. So everything is doing their job on its own. It's only for our understanding and our mathematical model and what application we can derive out of that. That is the question mark. So when we do the wave motion, linear, so we can separate this as a linear and circular. Okay. Linear motion and circular motion. Remember the simple harmonic motion and the pendulum and all those stuff. Remember that?
Yes.
You're
Yes.
okay with all those things?
Yes, uncle.
Okay. And then the wave is, okay, it can be a mechanical wave, like a sound, right? Sound wave. That is an example. And it could be something like a heat wave. They are all like electromagnetic wave. Okay. Electromagnetic wave. So in the electromagnetic wave, in short form, we call that as a EMW. And in there, one particular band is light. Okay. And in the light itself has a nature, like it can behave like a wave or it can behave like a particle. Okay. So why I started from all the way from dynamics and object motion and everything, there is a connection between the circular motion and the wave mechanics and even the light property and all those stuff, they have a connection. So when we learn one thing and when we learn the other thing, we need to make the connection from A to B and B to A, and we need to have the foundation very strong with that. Is that okay?
Yes, uncle.
Okay. So quickly, I will tell you, we did this long time ago when the that is case 0, case 1, case 2, case 3 and everything. I go directly to the case 2. If I write it, you will recall what I'm saying. Let's say the acceleration is constant. Is that okay? That
Yes,
means we say the dA by dt is actually equal to 0. So if
yes.
this is the case, and also we defined acceleration is nothing but rate of change of velocity with respect to time, and velocity itself is defined as rate of change of displacement with respect to time, and displacement itself is a basic quantity which cannot be derived from any other quantity, is measured in terms of meters, and time is also a basic quantity which cannot be explained or derived from any other quantity. So this also a basic one measured in terms of second. So these are all very basic quantities, natural quantities. Okay. So that is how we build up. So once we start thinking about if they are stationary, there is no displacement, means we don't need to think about whether the S is function of t or not. Okay.
Yes.
But when the S is changing, then immediately we say that S is a function of t. So the S could be a function of t. That leads to the interesting point. You remember that we put the tabular column and start finding the difference and everything. Immediately this made us to go over here. Then we check that ds by dt, the change happened with the displacement with respect to the corresponding change happened with the time, whether this is a constant or not. If it is a constant, we don't need to worry further. Then we know how to make the case 1. So this one will be the case 1, where we simply say that the S of t can be calculated as simply the constant velocity multiplied by the time. Okay, case 1 is, we are saying that the case 1 is dv by dt is 0. Understand that?
Yes, sir.
Okay. And that is the same thing. As it is going to be time varying, then we say that this is going to be a v of t. When this is time varying, then we go for the next definition. Then that is why it is a case 2, and the case 2 is a is a constant, means we know how to model and everything. We say that v is actually equal to u plus at, and s is equal to ut plus of at square, and the third one is v square is equal to u square plus 2as. Is that okay?
Yes, sir.
These are all for the linear motion. So I put it them all as a linear motion. No periodic nature or something like that. Let's say we start walking and keep walking in one direction, keep on going, do that, all this thing comes into picture. Is it okay?
Yes, sir.
Okay, so far. So now I need to add a page. How to add a page? Usually the document after filled, it will make a new page, right? Okay, let me insert blank page. Okay. Okay, it is done. But okay, I should not have done at the top. I need to start put the cursor. I cannot put the cursor here, right?
Oh, right, because
it is all
yeah.
word is not sensing it. Okay. Okay. We need to think a bit what to do. If I insert a page break is going to, okay, this will keep on going to do like this. No. I want to insert a page that should go here as a insert should give me an option, right? After this page or
you can't, even if you press enter, it's not going to come to the next one, right? The cursor, even if you press enter.
yeah, but that will do. That will keep doing it. That is a stupid way of doing that. Like I have to keep entering this until okay, that is taking everything out.
Oh, it is okay.
You see that? I don't want to push any of this to the next page, right?
Okay. Usually we'll say add, it's going to. Not.
Okay, this is a thing we need to look into that.
But this one, it's taking it as an image or
Yeah, it's a kind of thing because this is because the text, the original software is not meant for writing on this. So
yeah, yes.
working with the cursor. So we need to make the cursor filled up with something, but all this content. So we should have already made the enter all the way to go to the next page, and we should have come and written on this. Do you get that? That is why
Yes, sir.
I'm stopping now. Okay, let it be. I will start a new document and write it in there. So when we start, all we need to do is already we need to insert pages. Do you get that?
Yes, uncle.
Insert blank page. Okay, then that means that will be available so that we can start working on this. Do you get that?
Yes. Yes, sir.
And when we go to the enter, we can insert the new page there. Okay, so let's continue here. I will save it as a single file and then send it to you later. Okay.
Okay.
Why I brought all these things now when you asked for light or something like that. Okay. Very simple. Like when we are thinking about doing the wave optics and everything.
Uncle, I can't see the new document. I can only see the old one.
Is it? So it is
think-
completing is a word. It should use that, right? Okay.
So share the new.
Yeah, there is a second document. I need to go there. Okay. Can you see that now?
Ah, yes, uncle. Now I can see it.
Okay. So what is the basics of a wave motion is you have a circular motion. Okay. So we have the second motion, circular motion. So it is for the human understanding. We simply say that, let's say there is some quantity which is having its own magnitude as a, and let's say this a is, let's say for time being is fixed with respect to time in a position. Do you get that?
Yes,
but
uncle.
it has the ability to make the circular motion. But let's say it is fixed. We have a reference here. So the reference is, this is angle theta equal to 0 radian. Is that okay?
Yes, uncle.
Okay. Then let's say this is a particular, this angle is a theta. Let's call that as a theta naught. Okay. Which is, in this case, it is negative, but let it be. But we can write this as a quantity A with an angle theta naught. Makes sense to you?
Yes, uncle.
So in the circular motion, this is at rest. This is not moving or anything. So this is our case 0. Is that okay? I'm comparing
Okay.
with our linear motion, something at rest. Then we don't need to. So here, like there are two quantity. The theta, which is measured in, normally we call that as a radian, and the time in seconds. These two quantity are the equivalent for the, in the linear motion, we have the S in terms of meter, comma, time in terms of second. Do you see the analogy? This is linear motion.
Yes.
Linear motion. And we know things about this very well, about all these things. I hope you know, even if the acceleration is constant, we know we need to go to the next order. You remember that, right?
Yes, sir.
All those things. But in the circular motion, the equivalent is, this is called the angular displacement. Angular displacement. That's it.
Okay.
Displacement. And for the understanding, at rest like this, and we know that what is K0 at rest means we say d theta by dt is 0. Makes sense to you?
Yes, uncle.
That means nothing is moving. So this will, we do the same thing, like same analysis and everything. All we are going to say is, this is nothing but there is some magnitude and it is at fixed at a value because theta is at a initial value theta naught. That's it. Do you understand that?
Yes, uncle.
And if I write this as a in the a e power I theta naught, you're okay with that?
Yes, uncle.
You understand this? You remember this complex way of writing this, right?
Oh, okay. Yes.
Okay. In general, we call whatever the quantity written as, this is as a, even though this is sometimes people call that as an angle, but the correct word, physical word is phase. Okay. So this is our magnitude and this is our phase. This is a time independent phase in this case, but it is called a constant phase in this constant phase. The phase word comes from, it is like, look at the diagram. For that instant, it is, அதாவது நம்ம தமிழ்ல சொல்லணும்னா இந்த கட்டத்துல இருக்கு அப்படின்னு சொல்லுவோம். இப்ப ஒரு மூவி போயிட்டு இருக்குன்னா இது வந்து ஓகே இன்ட்ரோல் கட்டத்துல இருக்குது, கிளைமேக்ஸ் கட்டத்துல இருக்குது, இப்பதான் படம் ஆரம்பிச்சுது அப்படின்னு அப்படி சொல்றோம்ல.
Yes, sir.
That is the phase of something. Do you get that? So the dynamics may happen, but in this case, it is at a constant phase. So with respect to 0, it is having an initial angle, but it is fixed at that point. That's why the phase is constant. Makes sense to you?
Yes, uncle.
Okay. So when we go for the case 1, now I leave it to you to think about and understand. Okay, before case 1, I would even write the meaning out of that, because they normally don't help the student to understand this. This mathematics has to be used here. Okay. So A e power I theta, what is the expansion for this? A times in the trigonometry.
A times not
E power I theta is a cos theta plus I sin theta.
Okay.
Okay, need to recall that. Basic, very simple. Let's say you take a quadrant and let's say you have a quantity somewhere which is a length, and we are saying that this is the theta. Actually, this is our
that is the cos.
A cos theta. Do you get that?
Yeah. Yes.
This quantity
Y will be the A sin theta. A sin theta.
And we know that this is our real axis and this is our imaginary axis.
Okay.
The unit quantity in here is a 1. The unit quantity here is a I.
Okay.
So for all this purpose, this is actually IA sin theta. So this point is actually A cos theta plus IA sin theta. Do you get that?
Okay, yes.
Which is actually written as A can be factorized. That will become cos theta plus I sin theta. And we have the Euler identity. This whole thing is nothing but our e power I theta. Is that okay? Do you get that?
Yes, sir.
Because you see, in a right angle triangle, we all learn in a reverse way, because that is how the mathematics has been developed. Even before, I don't know how many years ago, how many thousands of years ago, Pythagoras already learned this, understood this, and he did that. So let's say there is a ABC and one of their angle is a right angle for the given triangle, then the A squared must be equal to B squared plus C squared.
Yes.
That, and we just follow that, but this is actually taking care of only the magnitude. Do you get that?
Yes, sir.
Completely the squaring and everything is thrown away, the direction or the phase part is completely gone away. Then we developed ourselves. Okay, then we started putting the angle as the next thing, and the trigonometry and everything is developed. Use the same ACB. Then this theta is playing a vital role. This can be also written as a cos theta, and C can be written as a sin theta.
Yes,
then, if you try to write the Pythagoras for this, that will be A squared is actually equal to A square can be factorized on the other side. So this will be our cos square theta plus sin square theta.
Okay, yes.
And that makes that makes the cos square theta plus sin square theta equal to 1. Do you get that?
Yes, uncle.
Okay, so that is another identity which is quite useful for us. But even in this case, the magnitude is only there. Do you get that?
Yes,
but
uncle.
The angle theta is completely gone. So that is where the magnitude and phase. That is very important. Do you get that?
Okay, yes, uncle.
Put together only we can say that. For application wise, I would say that let's say a person is standing here, and this person is want to make a step. I'm drawing this from the top point of view. Do you get that? So
Yes,
if you
uncle.
make a step, he can make a step anywhere around him. Do you get that?
Okay, yes, uncle.
If he step on this side, we say that positive one step. When he make a step on this side, we say that
Negative one.
one step. And if we make a step on this side, then we need to make the mixture of positive one and negative one and everything. You remember the exercise, I know that this become a positive I.
Yes, uncle.
And if you make a step here, it become a negative I. And if you make anywhere, because this is actually meaning 0 radian, and this is a pi by 2.
Pi by 2, pi.
This is a pi. Do you see how the phase is inherently with everything, but we are not connecting that is actually making this to everything is all separated. Actually, all of them are connected. If you bring the direction and the phase, whatever is needed to completely describe that quantity, then everything will fall in place and we can connect them and learn about them. Is that okay?
Yes, uncle.
Okay, so when the magnitude and the phase put together, use the same diagram. So that is what I was drawing. So we have this reference XY axis. Let's say there is a quantity which is our A. Then Pythagoras is simple. The same thing. The step over here will be, as long as this is a theta, then we say this is a cos theta. And this is our IA sin theta. So if Pythagoras already thought about mixing the positive and negative numbers to make the I, which is a square root of -1, he would have written the Pythagoras not in the magnitude form. He could have written directly the length A, which includes both the phase and the magnitude. Do you understand that?
Yes, uncle.
And that is nothing but A cos theta plus IA sin theta. Do you get that?
Okay. Yes, uncle.
This is exactly Pythagoras, but Pythagoras proposed only in the magnitude form, because at that time, you know how many years ago? It was 2500 or something. At that time, nobody thought that the angle has to be always considered and put together when we are doing this kind of mathematics. Do you get that?
Okay, yes, uncle.
He went for only the area. Area is squaring. So he went
Okay.
in and he calculated everything worked. But it took only 400 years ago, Euler did that.
Okay, yes.
That is also accidentally he got it while solving the differential equation. But once we got this form, and that goes to, okay, let me go to the next. Any question or anything so far?
No.
Okay, let me go over here. I will insert here blank page. No.
Oh, okay.
That is not going. Let's say I go to the cursor here, then I press the blank page. This is okay, right?
Yes, sir.
That one and this one. Okay, let's go to this page and go to draw. It's a bit of an exercise. Let it be. So all we got was E just did it as E power I theta is nothing but cos theta plus I sin theta. And without this, we could have never made this world so modernized. I mean, all the electronics and all the instrumentation, computer, everything, even the understanding of the wave, light, how it works, AC signal and everything, all based on that.
Okay.
Do you understand that? So
yes.
This is actually for anything. E power I theta. Theta is the angular displacement. Do you understand? For the circular motion. Okay. Now go to case 1. Case 1 is, we are saying, okay, we start with something which is at an angle. So we say that it has a magnitude length, which is our, even for easy understanding, I can put it as a length, but it is making an initial angle of theta naught from the 0 position. And this is at a time t equal to 0. Is that okay?
Yes, uncle.
and we start the experiment at time t equal to 0, but this particular quantity is keep rotating at a constant period. That means when it completes the full 2 pi at the center, we say that the time becomes capital T. We call that as a period. Makes sense to you?
Yes, sir.
And this is constant. So when you go to the, so this is for angle. So this is at theta. So theta of 0 is 0 radian. And here we say that the theta of t is, okay, t is, how much radian is this? 2 pi. It completes one cycle.
Okay. Yes.
When t equal to 2t, 2 period, then we say theta of 2t is
2 theta.
Okay, it is 4 pi. Do you get that? It covers. So the time taken to complete each cycle is capital T, fixed amount.
Okay. Yes,
So,
uncle.
so you see the circular motion repeating again and again and again.
Yes,
but the
uncle.
time taken is constant. Do you get that?
Okay. Oh, 2t. Okay. Understood. Yes, uncle. Understood.
Okay, so when you go to the t equal to 3, so third cycle when it completes, that is how much angle covered up to that point will be 3t. So that is equal to 6 pi. Do you get that?
Okay. Yes, uncle.
So it is just coming back to the same position again and again.
Yeah,
Do you get that? Okay.
Yes.
So we do the same exercise. So the rate of change of, so d theta by dt, this is what we will be interested in. Do you get that?
Okay. Yes.
Okay. So this is actually a constant. This is actually going to be a constant. Do you get that?
Okay.
Why it is a constant? It takes the same time to complete that angle, the same amount of angle again and again and again. How we say that it is a constant? Let's say this quantity, we define omega, which is actually our angular velocity. Angular velocity in the circular motion, also called the angular frequency.
Yes, uncle.
That is in the wave mechanics. Frequency. This is for the circular motion. Circular motion. Motions, the pendulum motion, simple harmonic motion, all comes under this. So this is for the material circular motion, object circular motion, but angular frequency is for the wave. Is that okay?
Yes, uncle.
But the mathematical model will be exactly the same for both the cases. This is actually d theta by dt. Now we do a very simple thing. We know that d theta can also be written as a sum theta 2 minus theta 1 divided by t2 minus t1. Do you get that?
Yes, uncle.
So if you use any particular fixed value, like for example, 2 pi happened at the time of capital T minus 0, and this happened at the time t equal to 0. Makes sense to you?
Yes, uncle.
I'm just using these 2 points. Do you get that? These
Yes,
2
uncle.
points for the, we can take any 2 points, but it is going to give you the same value, because we are going to say that omega is a constant for this particular case. So this makes us omega is nothing but 2 pi over capital T. And also, I think we have already discussed about that. There is a linear frequency called F. Frequency F is 1 over T. Remember that?
Yes, uncle.
Frequency F is 1 over T.
1 over T.
We are asking if T time, capital T time takes to complete one cycle, then how many cycles will be done in 1 second? That is what frequency is. Makes sense to you? Capital T is the time. Okay, let me put it like, let's say it takes, completes 1 cycle in a t equal to capital T seconds. Is that okay?
Okay, yes, uncle.
Okay, so we are saying that in t second, we complete 1 cycle.
Okay, yes, uncle.
Okay, so this is time and this is cycles. You get that?
Yes, uncle. Yeah.
And immediately, I think I have explained this for anything. When we know something is related to the other quantity, immediately we need to think about for one amount, for 1 second, how much it is. We get that. How to convert the t to the 1?
Divide by t.
Divide by
Okay.
t. Okay.
Okay.
So
Yes,
as they are related, we need to do the same mathematics on the other side. Divide by t, it will be 1 over t cycles.
okay. Yes, uncle.
You get that? So this quantity relationship is a very beautiful one. We are saying that if capital T is the time taken to complete one cycle, then in 1 second, 1 over T cycles will be completed. So we define this as F. F is defined as 1 over T. That is our frequency.
Yes.
So think about it. Let's say it takes 2 seconds to complete a cycle. Then what is the frequency?
Should be two by t.
No, you are pushing yourself to use the formula and everything. Feel it. Okay, I'm saying that it takes 2 seconds to complete a cycle.
Okay. Yes, uncle.
What is the frequency? Frequency is nothing but in 1 second, how many cycles it will complete. So it takes 2 seconds to complete a 1 cycle. In 1 second, how much it can do?
1 by 2.
Only half a cycle. Do you get that?
Yes, sir.
You understand that?
Yes, sir.
Let's say it takes 1 millisecond to complete a cycle. Then what is the frequency? So millisecond is connected to second. How many milliseconds are there in a second?
1,000, right?
1,000 of them. So if you give 1 second for such a circular motion, which takes only 1 millisecond to complete, it will do
1
1,000.
by 1,000.
Yeah, it will do 1,000 cycles. Do you get that?
Yeah, yes, sir.
So if the period is 1 millisecond, then the frequency automatically become 1,000.
1,000. Yeah.
That is 1,000 per second. We have another unit for that called the hertz. So
Okay.
the 1 over second, to honor the scientist, we go for hertz. Is that okay?
Okay.
You see how we connect and relate, and even we need to think physically because we are learning physics. Makes sense to you?
Yes, sir.
Okay. So I put all these things for the simple case, like for the case 1, omega is actually 2 pi over capital T. Then write the 2 pi multiplied by 1 over capital T. I just separate them. Then 2 pi 1
Pi.
over T is a F. Do you get that?
Yes, sir.
So nothing is a formula. You see that, right? Because F is actually given by 1 over T. That means omega is also given by 2 pi F. Okay. And this is a constant for the case 1. Is that okay? Are you with me up to here? You're okay? Hello?
Uncle, can you hear me?
Yeah. Are you okay up to here?
Yes, sir.
Okay. So now let's go back and try to complete the model. So we have a starting point of a particular magnitude, let's say theta naught, and it is making a cycle again and again and again at a rate of omega, which is defined as the rate of angular displacement with respect to time. Do you get that? Which is a constant, which is a 2 pi F. Hello?
Yes, uncle.
Yeah, okay. Now we know that d theta by dt is actually equal to omega. Do the same exercise. So we can write d theta is actually omega dt, and we integrate both sides. This is d theta equals omega is a constant that can be taken out, integral dt. Are you okay up to here?
Yes, sir.
And we put at the time t equal to 0, the angle is theta naught. Makes sense to you?
Yes, sir.
And when the time is any time, then the angle will be the angle corresponding to that time. Is that okay?
Yes, sir.
Okay, let me get back to the page here and then insert blank page. And then we go back here. Bit of an exercise we have to do every time. Okay, now draw. So we have integral d theta, theta naught to theta of t, which is actually equal to omega integral 0 to t dt. Makes sense to you what we are
Yes.
doing?
Yes,
So
sir.
to complete the integration, that will be theta with a limit of theta naught to theta of t equals omega. The time has to be from 0 to t. So that makes us theta of t minus theta naught should be equal to omega t. Is that okay?
Yes. Yes, sir.
Then we say the the constant angular velocity, the angular displacement can be calculated by whatever the initial angle
E plus
plus,
theta.
yeah, the linearly varying angle rate multiplied by whatever the time we are. Makes sense to
Yes.
you?
Yes.
Okay. So this is what is happening. So now the case 1 is, it is starting at an angle with a length A, it keep rotating at that. So we can write this straight away, as we know that this can be written in the Euler form A e power I theta of t. Now it is a time dependent one. Do you get that?
Yes,
So
sir.
this become a times cos of theta of t
Okay.
plus I
I
sin theta of t.
theta. Yes. Sir.
Okay. So I don't know whether I have shown this diagram to you, but I don't know whether, I'm not sure. Let's see. I bring the diagram and then see that whether that is making sense to you. Okay. 1 second. Remember this diagram? Did I show you?
No, no, uncle.
Okay, let it be. It's okay. But all we were talking so far was we are having a something at an angle. Do you get that?
Okay. Yes, uncle.
So something, no, this I cannot draw on this. This is a problem now. Oh, okay, I could do that. So let's say, let's take anywhere. Okay, I start it at now. In this case, we start it as a 0. Is that okay? Starting at 0. Do you get that?
Yes, uncle.
And
Yes, uncle.
it is going to make a rotation. Do you get that?
Okay.
And that rotation, and we know any position can be seen as a e power I times the initial value is a 0. So we can write only the omega theta not equal to 0 in this case. You are okay with that? So for what we discussed. And this will become simply omega t.
Okay. Yes, uncle. Understood.
But if the theta naught is non-zero, then we can write it as omega t plus theta naught. Do you understand that?
Yes, uncle.
But in this, I want to show you that this is nothing but a sine omega t. That's why I put the theta naught equal to 0 for simplicity. Do you get that? So this something is rotating in a circular motion. Do you get that? Keep rotating. And when you look at from this side, just to look at from this side, what you will see at time t equal to 0, you will see a dot. Do you get that? This whole line cannot be seen if you see from this side. The whole line will be seen as a dot. Makes sense to you?
Yes, uncle.
Because that is the projection on the vertical axis. So as it is rotating, when it goes to pi by 2, you will see the full length. You get that?
Yes, uncle.
And when it comes to pi, you see again a dot.
Okay.
And when it's 3 pi by 2, you will see the negative. So it will become a 0 plus a, and this become a 0 again, and this become a minus a, and this become a 0 again. Do you get that?
Yes, uncle.
So when we look at from this side, what is happening on the vertical axis will be the sine wave. Do you get that? And that is
Yes.
what this is.
Okay.
Get that?
Yes, uncle.
So that can be written as a sine of omega t. Sense to you? Makes sense to you completely?
Yes, yes.
Same thing if you see on the horizontal. If you see on the horizontal axis, it will start with an A value. Do you get that? At time t equal to 0, the full A will be seen, positive A.
Yes, sir.
And when it goes to the pi by 2, you will see only the dot.
Okay.
And then when it goes to the pi, it will see the negative A. Do you get that?
Yes, sir.
So it will be rotating like that. So that is the cosine wave. Do you see the cosine wave here? I put it like this. So it starts at a length A. This is at angle theta equal to 0. And this is the theta equal to pi by 2.
Okay, yes.
You understand? I put it in the vertical axis. So all this is a circular motion. When you see only on the vertical axis, you will see that as a sine omega t.
Yes, uncle.
But if you see only on the horizontal axis, you will see a cos omega t. But if you look at exactly which one is rotating, it is some A. Do you get that? Which is rotating in time. This can be written actually, it captures both the sine and the cos. Actually, this is e power I omega t.
Okay, yes.
Makes sense to you?
Yes, sir.
So that is what the connection between the trigonometric function and even what is the connection between sine theta and sine omega t is simply a triangle which is having a fixed theta. Then we can say that, let's say this is our A to B. Okay, I will write it as a Y. Okay, YA. No, why this is not control Z is not working. I don't know. Okay. So when you have the right angle triangle, this is our theta, this is our X, and this is our Y. You get that?
Yes, sir.
And this is our A. So this is nothing but our A sine theta. And this is our A cos theta. This is for the case 0. Do you get that? I
Yes,
put
sir.
0 also so that it is a constant phase. So this is a case 0. But when you make the same right angle triangle, but now this theta is not constant. This theta is going to be time varying quantity. And we already derived this theta is whatever the omega t plus theta naught. Do you get that? The initial value plus omega naught. So now we are just saying this particular opposite side, that is what we are seeing as it may start at 0 and it can grow to the, let's say this is the A, it can grow all the way to the A and it can come back to the 0 and go back to the negative A.
Okay, and then
doing that again and again and again. That is what drawn in the time axis. When you draw in the time axis, let's say this is the theta naught value, some positive value, lead angle, lead phase. This is the theta naught. You get that?
yes, uncle.
And this will be making the sine wave from there. And the negative sign part will go like that. Do you understand this?
Yes, sir.
Okay, this is important because this is what we will be using in our, okay, this completes this thing. So I will take all these fundamentals so that when I explain in the wave optics, what is a refractive index, what is happening, what is refraction, and what happens, why the light is bending towards the normal or away from the normal, how the velocity is related to that, all these things can be connected back to here. Do you get that?
Okay. Yes, uncle.
Okay, quick question. What was the difficulty in the wave optics?
Difference between interference and diffraction.
Excellent. Do you see that? But we need all this wave mathematical form and why the sine wave or cosine wave looks like that, and the meaning of the phase, the constant phase that is going to play a vital role. We need to show that when both the light, when they are interfering, what is the phase difference between them? Then we are talking about it is traveling with a frequency omega, but there is a phase theta not attached with that.
Okay, yes, uncle.
So after it travels, even though the source may be the same source, we split into two different rays using a Young's double slit experiment, something like that. Then at the starting point, both of them are starting as a sin omega t and a sin omega t. But when they travel same distance, then they will meet at the same point and still they will be a sin omega t. No phase difference between them.
Yes, uncle.
But if they meet, if they travel a distance which has a phase difference of pi,
Omega t.
pi difference. That
Yes,
means
uncle.
it has gone exactly opposite direction. Do you get that? Opposite amplitude.
Yes.
The
Yes.
A and minus A will cancel each other, and there we will have a dark band.
Okay.
So
Yes,
whenever
uncle.
the path difference is going to give you a phase angle difference of 0, then they are at AA,
Fine.
then it will become a double the amount. Whenever
Okay.
they have a path difference of pi angle, then A minus A will become a 0. So that is where we have the interference pattern like a bright wave, bright band, dark band, and it goes like that. So as we know this mathematical model and the knowledge, what physically we can measure is the length, the gap between the two slit holes, and then the screen, where the screen is, and where the distance of the first bright band and the next bright band. We can use the trigonometry to even find what is the wavelength of the light or the frequency of the light. All those things can be indirectly measured. Do you get that?
Yes, uncle.
So, and the diffraction is actually bending of the light around the corner. So that is also with the grating and everything, we can understand what is going on. So we can look into that next week. Is that okay?
Yes, uncle.
Any questions?
No, uncle.
Okay then. Okay. See you then.
Thank you.
Okay, take care. Bye.